Hello class. Today we are going to begin our lecture on chapter 2.4, which is on dividing polynomials, and also talk about two additional theorems, the remainder theorem and the factor theorem. Now towards the end of the previous lecture, I had told you that in the next topic we will start looking into handling polynomials which are of a higher degree and also which are not factorable. These tools of dividing polynomials by different ways, and also the two theorems here, the remainder and the factor theorem, are going to help us in the process of understanding polynomials of a higher degree and also to graph them. Now first let's look at the topics that we are going to cover in this lecture. We are going to talk about dividing polynomials, and dividing polynomials can be done in two ways. One is the long division method and the other is the synthetic division method. And as you will see, the synthetic division method is a little bit different from the long division method, but it's very fast and also very convenient to divide polynomials using that method. Then we'll talk about evaluating a polynomial using the remainder theorem, and then use the factor theorem to solve a polynomial equation. All right. Now, before we talk about the long division of polynomials, I would first like to remind you the process of performing an arithmetic long division manually. Nowadays, we usually would use a calculator to perform arithmetic long division, but we need to know the process, or rather knowing the process, step-by-step process behind a long division will help us perform long division on polynomials, because we'll be using pretty much the same process. All right, so I'm just going to take a number here. Let's say number 3983. Let me get my pen out. All right, 3983. That is the number I'm going to divide by 26. Now the number that we are dividing, in this case 3983, is usually called the dividend, and 26, that's the number we are dividing the dividend by, is called the divisor. Okay, we will be referring to these terms later on. That's why I just want to introduce you to the terms here in case you are not aware, not familiar. So what are the steps? How do we go about performing this long division? We first kind of separate the digits of the dividend and tackle them piece by piece. All right, we see what is the smallest value in 3983. What is the smallest value that 26 goes into? All right, so let's look at the first digit. The first digit is a 3. 3 is too small for 26 to go into. Then if we take the next digit, if we take two digits, 39, 39 is greater than 26, and 26 goes into 39 once, correct? So I'm going to write 1 over here on top, and 26, I'm going to multiply 26 by 1. Let me take out my pointer. I'm going to multiply 26 by 1. 26 times 1 is 26, so I'm going to write 26 here. Right? And then in the next step, what we do is we subtract 26 from 39, right? So we subtract. I'm going to write a visible minus sign. That's the next step, all right? So when you do 26 times 1, you wrote this as a positive number, and then in the next step, we are going to subtract. All right, I'm just stressing on these steps, all right, because we are going to be using the same thing. We have to remember the same steps when performing polynomial long division. All right, so now let's do 39 minus 26. 9 minus 6 is 3. And let me change the color. Okay, 9 minus 6 is 3. 3 minus 2 is 1. All right, and we start the process all over again. Does 26 go into 13? No, 13 is too small for 26 to go into. So we bring down the next digit, which is an 8. All right, we bring down the next digit. So digit by digit we proceed. All right, so bring down the 8 and we have 138. And now let's see how many times 26 goes into 138. All right, so that would be 5. All right, so 5 times 26. If we do 5 times 26, it's 130. All right, so we write the 130 below 138, and in the next step, we subtract. All right, we write the 130 as is, right? 26 times 5 is positive 130. So just write it as 130 and then you are subtracting. So I'll put the minus sign here and we continue. 138 minus 130 is 8. And we have another digit still remaining in the dividend, which is a 3. So now I'm going to bring down the 3 because 26 does not go into 8. So I'll have 83. All right. So how many times does 26 go into 83? It's 3 times, right? So let's see. 6 times 3 is 18. 3 2s are 6. 7, 78. All right. So now again we do a subtraction. 83 minus 78. And that gives us 5. Right? And we stop here because there are no more digits. There are no more digits in the in our dividend. We've completed the division at this point. Now, what is the result of or result from this division? 153 is what is called the quotient. All right, quotient, and 5 is called the remainder. Right, 5 is called the remainder. And the way we write the answer, the proper way to write the long division answer is like this. You start with the quotient, which is 153, and then plus, all right, so it's 153, which is the quotient. You write that first, and then 5, write the remainder 5 divided by 26. All right, so let me write here 153 is the quotient plus 5 is the remainder divided by the divisor. All right, so we have to write it as 5 divided by 26 because you can keep going with the division by putting a decimal point and bringing down zeros. All right, we can continue as long as we want to. All right, giving us a decimal value for a quotient, but normally we would stop here. Okay. So that's the process of arithmetic long division. Another thing is that we should know is that when we multiply the quotient times the divisor plus the remainder gives us back the dividend. Now that we've gone through the process of arithmetic long division, let's work on some polynomial divisions using the same process and see how that works out. All right. So I'm going to write here polynomial division. It's x squared plus 10x plus 21. So which is going to be our dividend. And I'm going to divide the dividend by x plus 3, which is our divisor. All right, so I'm going to first write it in long division form, which is, so the dividend comes here, and then let's put the long division sign, and x plus 3 goes here as the divisor. All right, so how do we start this process? Remember that the divisor is a binomial. So what we will be doing is we will take two terms together from the dividend and work them together. All right, two terms at a time. Why? Because the divisor is also two terms. It's a binomial. All right, so we are going to work with two terms from the dividend at a time. Now, to figure out what we should put in the quotient, just look at the first term of the dividend. It's x squared. What is the first term of the divisor? It's x. And think, what should you multiply this x by to get an x squared? All right, because the process involves canceling out one term at a time. So we have to think what we can multiply the first term in the divisor to match the first term in the dividend, which is an x squared. So x times x is x squared, correct? If we multiply this x by another x, we will end up with x squared. And that's what we are going to do. I'm going to write here x, just x. And then remember, this is a binomial. All right, so what you have to do is you have to multiply this x with x plus 3, both the terms. All right, so x times x is x squared. So I'm going to write here x squared below, okay, x squared. And then you also have to multiply this x with the 3. So plus 3 times x is plus 3x, correct? So I'm going to write here plus 3x. All right, so make sure that the terms are aligned. All right, the terms below are aligned with the ones above. And now I'm going to put a line under this, and remember what we did in arithmetic long division. We were subtracting at each step, correct? Here too, we do the same thing. So we have to subtract x squared plus 3x we have to subtract x squared plus 3x from x squared plus 10x. So subtraction means it involves a negative, so I write, so it's minus. However, when we put a minus sign on the first term, we have to do the same thing to the second term. So this plus becomes a minus. So the signs basically change, all right? Previously, this was plus x squared. I'm trying to pull up my pointer here, so I had plus x squared and plus 3x, just change the signs. All right, make it minus x squared and minus 3x. So x squared minus x squared becomes a 0. All right, it becomes a 0. So we have cancelled out the first term, and 10x minus 3x is plus 7x. Correct? Plus 7x. Now we bring down the plus 21, all right, which is the third term in our dividend. Bring that down, and now we have plus 21. Just like in arithmetic long division, we were bringing down the digits at each step. Here too, we bring down the terms. So now we have 7x plus 21, and the process continues. We have to think of what we should multiply the x with in the divisor to get a 7x. All right, because our aim, our goal is to get rid of this 7x. So think of what you should multiply x with to get 7x. That would be positive 7, right? So positive 7 times x is plus 7x. So I'm going to write here in the quotient area plus 7. So x plus, we now just have 7. So 7 times x, again, we are just repeating the same process that we did the last time. So x times 7 is 7x. Let's write that down, 7x. And then 7 times 3. Don't forget this 3. X plus 3, this whole binomial is 1 unit. All right, so 7 times 3 is plus 21. And now we have to do the subtraction. And when we do the subtraction, the sign changes for both the terms. It changes for both the terms. So 7x minus 7x is 0. Plus 21 and minus 21 is also a 0. So that means we don't have a remainder. The remainder is 0. All right, so we have our quotient here, x plus 7. So the answer is going to be just x plus 7. We don't have a remainder. All right, x answer is x plus 7. I mean, we can write it as plus 0 over x plus 3, but it's not needed because 0 divided by anything is 0. All right. So that's the process of dividing polynomials. In the next slide, I'm going to work on another polynomial division, which is going to be a little more complex than this one. This one was a fairly easy one. I'm going to show you another polynomial division on a polynomial which is of a higher degree. Now let's perform this long division on a higher order polynomial. Okay, so the question says divide 2x to the 4th plus 3x cubed minus 7x minus 10, which is our dividend, by x squared minus 2x, which is our divisor. All right. Now, first, let's quickly check if the polynomial is arranged in proper order of descending exponent. So we have 4, 3, then x to the 1, and then x to the 0, which is 4 minus 10, right? And so is the divisor. We have to check that for both the dividend as well as the divisor. So now I'm going to write the long division format. Put everything in long division format. I'm going to write 2x to the fourth plus 3x cubed. Now I'm going to take a pause at this point and explain something to you. We see over here that although the polynomial is arranged from from the highest to the lowest exponent, after 3x cubed we have x to the 1. All right, so there is x squared missing in this polynomial. All right, the term with x squared in it is missing. And the reason it's missing is because the exponent, or rather the coefficient of the x squared term is a 0. That's the reason this whole term became a 0, and we don't need to include it in the polynomial. All right. However, when we are performing the long division, it is important that we make that missing term visible. Otherwise, it's going to be difficult to perform the long division. All right. So I'm going to make this missing term between x cubed and x visible by writing it as 0x squared. Okay, so let's do that. Plus 0x squared, and then we continue minus 7x minus 10. All right, and then let's put the long division sign, and we write the divisor x squared minus 2x on the left side of the sign. Right, now we can continue with the long division process. The first step is to figure out what we should put in the quotient, in the first term of the quotient. So the place for the quotient is above the long division sign, correct? We have to figure out what the first term in the quotient should be. In order to do that, we look at the first term in the dividend and the first term in the divisor, and see what we must multiply x squared by in order to get 2x to the fourth. All right. Now x squared times 2 times x squared is 2x to the power 4, correct? If you multiply x squared by 2 times x squared, we will end up with 2x to the power 4, right? So I'm going to write up here in the place of the quotient as the first term 2x squared. Now, if you are unable to figure out by just looking at it, or do it mentally, what you should put in the quotient, just do this. Take the 2x to the fourth of the dividend, and on the side perform this division. 2x to the power 4 and divide it by x squared. All right, and you will end up with 2x squared. You will get what should go on the quotient. All right, again here we are doing a division of exponents, and the quotient rule for division is we subtract the exponents, right? So 4 minus 2 is 2, and that's why we put x squared. And of course, there's the 2, so 2 times x squared. So now that we got the quotient term, we have to multiply 2x squared with both the terms in the divisor. All right, so x squared as well as minus 2x have to be divided by 2x squared. All right, so 2x squared times x squared is 2x to the fourth, and make sure you are aligning the terms to make it easy for you to do the subtraction. All right, and 2x squared minus 2x is minus 4x cubed, correct? 2 times negative 2 is negative 4, and x squared times x is x cubed. And now we have to do the subtraction. Now my strong recommendation is, my suggestion is, show that you are changing the signs. All right, it'll make things easier for you and prevent you from making mistakes. All right, making errors. So I'm going to show that I changed my signs for both the terms here. So over here we have 2x to the fourth, right? Here we have positive 2x to the fourth. That should become a negative. And then for minus 4x cubed, when we change the sign, just cross it out and write the plus. All right, show that you've changed your sign. It'll be good for you, or easier for you uh, uh, to remember that, okay, you didn't forget to change the sign. So 2x to the fourth minus 2x to the fourth is a 0. And that's our goal. Always the first term should be made a 0. All right, that's the goal in performing the long division as we go through the steps. And plus 3x cubed plus 4x cubed is plus 7x cubed. All right, and now we bring down the next term, which is plus 0x squared. Plus 0x squared. All right, and we begin the process again. What should we multiply x squared with to get 7x cubed, which is the first term of the dividend at this level? All right. If you want, you can do the division on the side, which I'm going to do here. We have 7x cubed divided by x squared, which is the first term of the divisor, and we will end up with 7x. So if we multiply x squared by 7x, we will get 7x cubed. Good. So let's write that down up here on the quotient as the second term of the quotient. All right. And then let's do the multiplication. We multiply each of the terms in the divisor by positive 7x. So 7x times x squared is 7x cubed. 7x cubed, and 7x times negative 2x is negative 14x. All right, x squared, right? So just make sure that you also do the multiplication of the signs correctly. Plus times minus is minus. Then we change the sign. All right, so we have 7x cubed and 7x cubed at the bottom. So change the sign and show that you're changing the sign. I'm going to cross out the minus and change it to a plus. Okay, so to remind myself that yes, I did change the sign. And now 7x cubed minus 7x cubed is a 0. And 0x squared plus 14x squared is 14x squared. Right? And now we bring down the next term, which is minus 7x, and continue with the process. What should we multiply x squared with? What should we multiply x squared with to get 14x squared? All right. So if we multiply x squared by 14, and if you want, you can again do the division on the side. 14x squared divided by x squared is 14, and that's what you put in the quotient as the third term. So multiply x squared minus 2x by 14, and we get 14x squared. 14 times negative 2x is negative 28x. All right. Now change the signs. The first term becomes a minus. The second term, which had a minus, becomes a plus. We have changed the signs. So we now have 0 14x squared minus 14x squared is 0. And minus 7x plus 28x is plus 21x. All right, plus 21x. Bring down the minus 10. Bring down the minus 10. Now at this point, we see that the exponent in the dividend at this level is less than the exponent in the divisor. And when that happens, when you see that, you get to a point where the exponent in the dividend is less than the one in the divisor, you can stop. All right, we stop here, and our remainder is going to be 21x minus 10. We are left with a remainder of 21x minus 10. All right, this is our quotient. Let me write that. This is the quotient. And to write the answer, all right, to write the answer in the correct form, this is what you must do, all right? We have 2x squared. So let me write it here. Answer, or here, answer. Actually, we don't have enough space. So what I'm going to do is I'm going to delete this part and write the answer at the bottom. I need some space to write the answer in a single line. All right. Answer is the quotient, which is 2x squared plus 7x plus 14. All right, I'm going to surround that in brackets because the quotient is a unit. All three terms form a unit. And then plus, you put the remainder, which is 21x minus 10, and surround that by brackets as well, divided by, the remainder should be shown as being divided by x squared minus 2x. All right, so that's the right way of expressing the answer of a polynomial division. All right, now another thing is we can get back our, and we will discuss this in a later slide as well, but I'll just mention that in passing. All right, we can get back our original function, the original dividend, the f of x, by writing it as 2. If we take the, well, quotient 2x squared plus 3x cubed minus 7x minus 10 and multiply it by, well, this is the original function. This is what we divided, right? F of x equals, if you take the quotient, which is 2x squared plus 7x plus 14, and multiply it by x squared minus 2x, all right, and then add the remainder, which is 21x minus 10 divided by x squared minus 2x, then you will get back the original dividend function. All right, we will discuss this a few slides down again. All right, so if you didn't quite get it, don't worry. All right, we will revisit this again. For this slide, just know how we performed this polynomial division. All right. So now that we have worked through some examples of long division of polynomials, let's read through the steps. It'll be a lot easier to follow what they're saying here. It says as step 1, arrange the terms of both the dividend and the divisor in descending powers of any variable. All right, and if there are any missing terms in the dividend or in the divisor, we have to make them visible by making the coefficient 0. All right, like we did in the previous example. Step 2, divide the first term in the dividend by the first term in the divisor. The result is the first term of the quotient, right? That's what I showed you, that we have to take the first term of the dividend and divide it by the first term of the divisor. Remember, I was doing that on the side to determine what the first term of the quotient, or what each term of the quotient would be. And then once we got the term to put in the quotient, we multiply every term in the divisor by the first term in the quotient. Write the resulting product beneath the dividend with like terms lined up, where I was saying that make sure that the terms are aligned so it's easy for you to do the subtraction. Then subtract the product from the dividend. In step 5, we bring down the next term in the original dividend and write it next to the remainder to form a new dividend. Use this new expression as the dividend and repeat this process until the remainder can no longer be divided. This will occur when the degree of the remainder is less than the degree of the divisor, and that's where we can stop. All right. Now, a few slides up, when I was doing the polynomial division, towards the very end of it, I had spoken about how to get back the original function, which is the dividend, by multiplying the quotient with the divisor and adding the remainder. All right, and I may have kind of covered it very speedily, but I said I would revisit it at a later slide. So this is the slide where we talk about it again. All right. Now this is uh, in an algebraic form that they have expressed what they call the division algorithm, but I will use an example first, an arithmetic example to explain this, and then maybe a polynomial example. All right. So the division of algorithm says if f of x and d of x are polynomials with d of x not equal to 0, the degree of d of x is less than or equal to the degree of f of x, then there exist unique polynomials q of x and r of x such that f of x equals d of x times q of x plus r of x. All right, I'm going to break this into parts and start the explanation because I know this is difficult to understand the way it's given here. So what they're saying is f of x, if f of x, think of f of x as the dividend, all right? Dividend, what we were dividing. F of x is the dividend. D of x is the divisor, what we are dividing the dividend by, the divisor. So d of x is the divisor, f of x is dividend, what is getting divided. All right. Now, in order to be able to perform a division, the exponent, or rather the degree of the divisor should be less or equal to the degree of the dividend. All right, degree meaning the exponent of the leading term in the polynomial. All right. So, given that there is a dividend and a divisor where the divisor is not equal to 0 and where the divisor has a degree which is less or equal to that of the dividend, then we can express the whole division in this form. F of x, which is the dividend, all right, f of x, again, let's write that down, otherwise it's very difficult to grasp, which is what? The dividend is equal to the divisor multiplied by the q of x is the quotient plus added, so we add the r of x, which is the remainder. All right, so dividend equals divisor times quotient plus remainder. So after we've performed the division, all right, if we take the divisor, multiply it by the quotient and add the remainder if there is any, then we will get back the dividend is what they are trying to say here. All right, so I'm going to just use a simple arithmetic division and show you what we mean. So let's say we have 44. All right, let me make it a little more, use a higher number. So 442, let's say I want to divide it by 10. All right, so 10 times 4 is 4. I write the 40 here. Sorry, 10 times 4 is 40. I write the 40 down here, 4 in the quotient, do the subtraction. For 44 minus 40 is a 4, bring down the 2. All right, and then 10 times 4 again is 40. So I write the 40 here. All right, do the subtraction. 42 minus 40 is a 2, and that's my remainder. All right, this is my remainder. This is my q of x or quotient. And this is my divisor. This is my divisor, 10, and this is my dividend. So based on this algorithm, what they are saying is f of x or the dividend 442, all right, which is the dividend, will be equal to the divisor, all right, 10 multiplied by the quotient, which is 44, plus 2, which is the remainder. So divisor, which is d of x, 44 is the quotient q of x, and 2 is our r of x. All right, so plus multiplied, and the dividend is our f of x. All right, so let's check quickly. 10 times 44 is 440 plus 2 is 442. All right, so that's what they were trying to say in this slide. And if we do the same thing with a polynomial division, after we perform a polynomial division, we can just cross-check, all right, by taking the divisor, multiplying it by the quotient, and adding the remainder to it, r of x. All right, it'll give back the dividend, whatever the original function was. All right. Now let's walk through this example that is given in this slide. It says divide 7 minus 11x minus 3x squared plus 2x cubed by x minus 3. So here is the dividend, and we see that this is not in proper polynomial order, in descending order of exponents, and x minus 3 is the divisor, right? So as part of step 1, we begin by writing the dividend in descending powers of x. That means 2x cubed should be the first term, then minus 3x squared should be the second term, minus 11x the third term, and 7 is the plus 7 is the should be the last term. Now we see that we have arranged it in descending order of the exponents 3, 2, 1, 0. All right, and keep in mind if any exponent is missing in the polynomial, then you have to bring it up, you have to show it, make it visible by putting a 0 as the coefficient of that term. All right. Now let's walk through the process that they have followed, and I'm going to suggest some changes to the way they have worked this through. All right. So we have the dividend, okay, under the long division symbol, 2x cubed minus 3x squared minus 11x plus 7, which we had arranged in proper polynomial order in the previous slide. And we see that there are no terms missing, so 3, 2, 1, and then the last one has x to the power 0, and that's why we don't see the x variable. So on the left hand side we see our divisor x minus 3. So let's get started with the process. All right, so the first thing is to find the first term of the quotient. Just a second, I'm trying to pull up my pointer here. All right, so we take the first term of the dividend, all right, and see what we should multiply this x by to get 2x cubed. All right, so remember what we can do to figure that out. Just take 2x cubed, and I'm doing that work on the side. 2x cubed divided by the first term of the divisor, which is x, and when we do the division, it's going to be 2x squared, and that 2x squared is going to be the first term in our quotient. Now, once we get this, the first term in the quotient, we multiply x minus 3 with 2x squared, correct? So 2x squared times x is positive 2x cubed, correct? And this is what I don't like in the way they have worked it. 2x squared times x should be positive 2x cubed. And that was the reason why I was saying previously that first write the signs, and then when you do the subtraction, cross the original signs and change the signs. All right, put the new subtraction sign. So I would write it as plus, all right, plus 2x cube initially when we do the multiplication. So 2x squared times x is plus 2x cube, and 2x squared times minus 3 is initially minus 6x squared, correct? And then when I do the subtraction, I would cross out the original sign that I obtained from the multiplication. All right, this minus will be changed to a plus, and the plus for 2x cubed is going to be changed to a minus. So 2x cubed minus 2x cubed is 0, so that's why you don't see a value here. But minus 3x squared plus 6x squared, 6 minus 3 is 3, so they have 3x squared, and then they bring down the minus 11x, the third term of the dividend, down, and now our new dividend is 3x squared minus 11x at this level. All right, and we start the process again. We have to find what we can multiply x by in order to get 3x squared. Again, you can follow the same process, just divide 3x squared by x and you will get 3x plus 3x. All right, so our signs are initially plus, I'm going to write that uh, it was plus 3x times x is plus 3x squared, and 3x times negative 3 is minus 9x to begin with. All right, when we do the multiplication, at that point it was minus 9x. But then when we do the subtraction, we have to change the sign. So I'm going to cross out the plus and put the minus, and I'm going to cross out the minus that was previously with 9x and change it to a plus. All right. So minus 11x plus 9x is minus 2x, correct? Minus 2x, and this term is zeroed out. So minus 2x, and then we bring down the fourth term from the original dividend. So this plus 7 comes down, and we follow the same process. So what should we multiply x with to get a minus 2x? Again, follow that same procedure. Minus 2x divided by x is negative 2, correct? It's negative 2. So initially, all right, initially this is going to be negative 2x. When we do the multiplication, minus 2 times x, and let me take out my pointer again. Minus 2 times x is minus 2x when we do the multiplication. All right, keep the sign the same when you're doing the multiplication. And minus 2 times negative 3 is a positive 6 at the time of multiplication. That's what it was. And then when you change the signs, cross out the initial sign and change it to a plus. So minus becomes a plus, and the plus, cancel out the plus and write the minus. All right, that way you know what the sign was at the time of multiplication, and that you have later on changed the sign and you've done the subtraction correctly. Otherwise you'll go wrong with the subtraction. So minus 2x plus 2x is 0, plus 7 times, plus 7 minus 6 is a 1, and that's a remainder, right? That's a remainder. We don't have to proceed after that. We can just stop here and write it in proper quotient form, proper long division answer form. So the quotient is 2x squared plus 3x minus 2. So just write that, and then plus whatever the remainder is, 1 divided by x minus 3, which is the divisor. All right. We are now going to learn a different procedure of performing the polynomial division. It's called the synthetic division, and as you will see that this is a much faster process and involves fewer steps than the long division method. Now, whether you're using the synthetic division or the long division method, we should get the same answers after the division is completed. All right. Now, the first thing that we have to know about synthetic division is how to set it up. We had a way of setting up the long division problem. In synthetic division, we first have to set it up, and then we can start performing the division. Now let's read the question given to us. It's called divide. It says divide 3x squared plus 7x minus 20 by x plus 5. So 3x squared plus 7x minus 20 is the dividend, and x plus 5 is our divisor. All right. Now in synthetic division, when we set it up, we are not concerned about the variables in the dividend. All we are concerned with is or are the coefficients of the different terms. All right, we work only with the coefficients of the different terms. So once we set up, we just extract, we just pull down the coefficients, and I'm going to write plus 3 for the first one. All right, the first term has a coefficient of plus 3, then it's plus 7, and it's good to write the sign also, even if it's positive, just write it as plus 7, because when we have a negative 20, all right, it will matter if you miss adding the sign. All right, so we have plus 3, plus 7, and minus 20, which are the coefficients of the three terms in the dividend. And then to the left hand side, just put an inverted L, which represents the symbol for synthetic division. All right, and then we have to put the, I'm sorry, this, okay, this is our L. And now we have to put a value to the left hand side of this symbol. Now that value is going to be the constant value in the divisor. The constant value of the divisor is going to be written here. However, it's not just plus 5. The divisor first has to be put in x minus c form. All right, it's very important that the divisor is first set up in x minus c form, and then we will extract the value of c from this form, and we are going to write it here. All right, so the divisor for us in our example is x plus 5. So I'm going to rewrite it in x minus c form. So this x, I'm going to write it as x. And then I have to show the minus sign, because that's exactly how the form is, right? So you have to make that minus visible. So there has to be a minus. I'm just transforming x plus 5 in the x minus c form. So once we extract the minus from the plus, what remains is minus 5, because minus times minus 5 is a positive 5, and we get back the divisor, that you know the expression of our divisor. But when we put it in x minus c form, the value of c is minus 5. All right, so again, c is the value after transforming, after setting x plus 5 in the x minus c form. C is not positive 5. All right, c is the value that you have after uh, transforming x plus 5, rewriting x plus 5 in the x minus c form. So I'm going to write that minus 5 over here on the left hand side. Okay, so now we have this partition between uh, between the coefficients of the dividend, and we have the divisor, so to speak, on the other side of the synthetic division symbol. And now the next thing that you do is leave some space under the coefficients and draw a line. All right, we need to leave some space because we will be using the space to write. All right, so the first thing is, for the first term, or the first coefficient, just write it as is beneath this line. All right, so we have a plus 3. I'm going to write the plus 3 below the line. All right, not here, but below the line. So I'm going to write plus 3. All right, plus 3 as is. And then in the next step, what we will do is we will multiply minus 5 with positive 3. This is multiplication, all right? We are multiplying, not adding, not subtracting. We are multiplying minus 5 with what is under the line plus 3. And it's minus 5 times positive 3 is minus 15. So I'm going to write minus 15 under the second term, all right? The second term was plus 7. The coefficient of the second term was plus 7. The result of multiplying minus 5 with plus 3 has to be placed under the second term, minus 15. All right, and then you just add the two values. All right, add plus 7 and minus 5. You don't have to change signs like we were doing in long division. Do not change signs, just add them. All right, plus 7 and minus 15 is negative 8, correct? It's negative 8. So we got negative 8. Negative 8 has to come below the line, and then you again multiply, and I'm going to use a different color now. You multiply minus 5 this time with minus 8. All right, again you are multiplying and writing the result, the answer, above the line below the third term, the coefficient of the third term. All right, so minus 5 times minus 8 is positive 40. So let's write that. Okay, it's going to be positive 40, and then you add it up. So minus 20 plus 40 is positive 20, and we are done. We've completed our synthetic division. As you can see, it was much faster than the long division method, and it involved fewer steps, right? Now, we got these values, plus 3, minus 8, and 20, but how do we translate those in polynomial form? We have to convert those and rewrite a polynomial expression. Otherwise, it doesn't make sense, all right? So we'll learn how to do that. So what we have below the line, okay, over here, plus 3, minus 8, and 20, can be divided into two parts. The last value, the end value, which is 20, will always be the remainder. All right, this value here, let me pull up my pen. 20 is going to be the remainder from the division. And the rest of the numbers are going to be the coefficients of the quotient. Remember, we have the quotient, and then we have the remainder, and then we have to put them together when we write the final answer in long division. Right? We're going to do the same thing here, but these are going to be the coefficients of the different terms of the quotient. So we are going to write the quotient first. So 3 is going to be the first term. We need an x, but what should we put for the exponent? All right. The exponent of x will be 1 less than what was in the first term of the original dividend. 1 less. So the first term in our original dividend was 2, correct? So in the quotient, it's going to be 1 less, so this is going to be x to the 1. So 3 times x, right? X to the 1 and x, same thing. So 3x, we leave it as 3x, and then the rest of the numbers are the coefficients of the subsequent terms of the quotient. So if this is 3x, the next one will just be minus 8. All right, so that is what our quotient is going to be. The remainder is 20, and we can put them together to get the final answer, which is 3x minus 8 plus 20 divided by, all right, go back to your original divisor and write that x plus 5. All right, if you want, you can put brackets around it. So we have 3x minus 8 plus 20 divided by x plus 5. Now, if you perform this division by the long division method, you should get the same answer as what we got here using the synthetic division method. You can try that out yourself and see if the answer matches or not. Now that we have worked through the steps of performing a synthetic division in an example, let's put the steps in words and see what the process. Let's summarize the steps. So let's see what they have here on this slide about the process of performing a synthetic division. The first step here says arrange the polynomial in descending powers with a zero coefficient for any missing term. So the first step, whether it's the dividend or the divisor, we have to make sure that they are arranged in proper polynomial order. That is, the exponents are arranged in descending order. All right. And if there are any missing terms, then we have to express them. We have to make them visible by rewriting them with a coefficient of 0. All right. So that was the same as what we did with long division. I think we had worked through an example where one of the terms were missing and we expressed that. I rewrote that as 0 times x squared or something like that. We have to do the same thing here. That step remains unchanged. In the next step, step 2, it says write C for the divisor x minus C. To the right, write the coefficients of the dividend. All right. So if just to remind you what we did in the previous example, we first converted our divisor. We converted our divisor into the x minus c form. It was x plus 3. Our divisor in our previous example was x plus, I think x plus 5. We had to rewrite that in the form x minus c, and we got x minus 5, and that minus 5, this minus 5 was the value of c. Okay, it was our value of c. So it says write c for the divisor x minus c. So I'm going to write minus 5 was what we had in the extreme left hand side, separated by the synthetic division symbol, and then it says to the right, write the coefficients of the dividend. So on the right hand side of the separation sign, we had, I think, a plus 3, a plus 7, and just to be consistent, let's put the signs, and a minus 20. All right. Step 3 says write the leading coefficient of the dividend on the bottom row. Write the leading coefficient. So the leading coefficient was 3, and I had asked you to draw a line leaving some space between the numbers above, and you had to, what we did was we just put the leading coefficient plus 3, okay, below the line. Right? That's what they are saying we have to do in step 3. Write the leading coefficient of the dividend on the bottom row. And then number 4 says multiply C times the value just written on the bottom row. So minus 5 times positive 3. That's what they are saying here. Multiply C. C is minus 5. The C times the value just written on the bottom row here, and write the product in the next column in the second row. So if you remember what we did, let me pull up my pen. We multiplied minus 5, which is a C. Minus 5 times positive 3 was minus 15. The result we put in at the bottom of the second term, right? So this was a minus 15, all right? And then what we did was we added the two values, right? Plus 7 minus 15 is minus 8, all right? And then we'll go to the next slide to see what the next step would be. So in step 5, it says add the values in this new column. So we were working through it. We had a plus 7 and then minus 15. We added them, all right, writing the sum in the bottom row. In the row below the line, we wrote a minus 8. Then repeat this series of multiplications and additions until all columns are filled in. And then finally, in the last step, use the numbers in the last row to write the quotient plus the remainder above the divisor. So remember, we had below the line, I think we had a 3, and then we had, what did we have? A minus 8, and then a 20, right? Once we completed the synthetic division, these were the numbers we had uh, below the line. Right? So use the numbers in the last row to write the quotient plus the remainder above the divisor. All right, so this is going to be our remainder. The degree of the first term, the degree of the first term of the quotient is 1 less than the degree of the first term of the dividend. So we had x squared in the first as the leading exponent, right? It was x squared. So this is going, the quotient, the first term in the quotient is going to be 1 less than x squared, so it's going to be 3x, and then minus 8, and then plus 20 over whatever it was, x plus 5. All right. The final value in this row is the remainder. That's what it's saying. The last value, the end value in the bottom row is always the remainder. The rest of the numbers are aligned to the quotient value. Let's look at this example that we have on this slide and go over it and see if it's following all the steps. So the example says use synthetic division to divide x cubed minus 7x minus 6 by x plus 2. All right. So here we see that a polynomial is arranged in descending order of the exponent. So first we have 3, then the next highest is 1 after that, and then last one is the constant term. And over here the divisor is x plus 2. So even though it's arranged in polynomial order, we do look for missing terms. All right, so we have 3 as an exponent and then 1. So x squared is missing. So we have to express the x squared by putting a 0, by using a 0 for its coefficient. So somewhere here there has to be a plus 0 x squared and then minus, minus 7x. Again, when we perform synthetic division, we are really not concerned about the variables. We are concerned with our interest is only the coefficients. All right. So let's look at the solution. It says the divisor must be in form x minus c. Okay, so they have tackled the divisor first. So this is x plus 2. We don't see a visible minus sign here. The form is x minus c. The form is x minus c. So we have to rewrite x plus 2 in this form of x minus c. So it's going to be x. We have to pull out a negative sign from the plus and we will have minus 2 for the value of c. So x minus minus 2. So c in this case has a value of -2. So it says the divisor must be in form x minus c. Thus we write x plus 2 as x minus minus 2 is exactly what we did here. This means that c equals -2. Now, writing a zero coefficient for the missing x squared term in the dividend is also needed. We can express the division as x cubed plus 0x squared, right, for the missing term. So minus 7x minus 6. But here we have kind of done it um, in long division. We have this format of a long division. So let's see, maybe in the next slide, they will set it up as synthetic division. Let's move ahead and see what happens. So here you see they have set it up in synthetic division format. So our coefficients were 1, 0, -7, and -6, correct? And they have the symbol for synthetic division, which is like an inverted L, and then C. Right, our divisor again was x plus 2. We transformed it into x minus c form and we came up with c equals -2, and that's what we put on the left hand side of our separator. Okay, and then what's the next step? We take the leading coefficient, which is 1, that means the first coefficient in our setup, and write that below the line. All right, so make sure you draw a line as a separator, otherwise you'll get confused which one is which. So bring down the leading coefficient, write it below the line, and then multiply -2 with 1. All right, so -2, and let me do that here with a pen. So -2 times +1, you're multiplying here, and write the result above the line below the second term, all right, in the setup, second coefficient. Okay. All right, so -2 times 1 is -2. So you write that below the second coefficient, or the second place of the second term, really, and then add. All right, do not change sign. So 0 minus 2 is -2. Repeat the process, -2, which is the c value. -2 times -2 is +4. So we are multiplying these two and writing the result below the third term, below the next term. All right, so -2 times -2 is +4. We write it below -7. Do the addition. -7 plus 4 is -3. Repeat the process. -2 times -3 is +6. Write the result below the next term. All right, the position of the next term. -6 plus 6, we do the addition, is a 0. All right, and we have completed our synthetic division. All that is left is to identify from the numbers below the line which is the remainder and which are the coefficients of the terms of the quotient. All right, again, the n term is always the remainder. So here the remainder is 0. There's no remainder. All right, and then the rest of the numbers will represent the coefficients of the quotient, all right, of the final answer. So we start with 1. All right, so 1 is the coefficient of the first term in the quotient 1. However, the variable will take an exponent which is 1 less than what was in the original polynomial, in the original dividend. I think it was x cubed. The first term was x cubed. All right, it was x cubed minus 7x squared minus 6, correct? That was our dividend. So because the first term had a 3, in the quotient we will have an exponent which is 1 less than the 3. All right. And then the subsequent terms will the subsequent terms will just have exponents 1 less than whatever the leading term is. So x squared minus 2x minus 3. There's no remainder, so you don't have to write it as plus 0 over uh, x plus 2. It's when the remainder is 0, just do not write the remainder. All right, that itself says there is no remainder. Now that we've learned about polynomial division using different techniques of synthetic division and long division, and we understand what the quotient is, what the remainder is, how to come up with those values, we will now go into what's called the remainder theorem related to polynomial division. So I'm first going to read through what the remainder theorem states here, and then we will um, try to understand it using an example. I'll explain it using an example. We use this problem to understand the process of synthetic division, and at that time we found that the remainder, and here we are just concerned about the remainder. The remainder after performing the division was, as far as I remember, it was 20. All right. So let me first read through the remainder theorem as stated in this slide. All right. It says if the polynomial f of x, so the f of x is the dividend polynomial. All right. So if the polynomial f of x is divided by x minus c, which represents our divisor, then the remainder is f of c. What that means is if we take the dividend polynomial, which in this case is 3x squared plus 7x minus 20, and evaluate it using c as the input value, then we will get an answer of 20, which is going to be the remainder when we do the polynomial division. That's all that the remainder theorem states. It states that if you take your dividend polynomial and evaluate this function using c as an input, so that means you replace all your x terms, all the x variables with c and perform the evaluation, you will get the a value which is equal to the remainder if you perform the division. All right. So let's go and verify that. Like I said, the remainder that we found after performing the synthetic division a few slides up was 20. So I'm going to plug in c into this function 3x squared plus 7x minus 20 and see if the answer we get is 20 or not once we go through the evaluation process. Now, mind you, we have to plug in the right value of c. In order to do that, the divisor that's given to us must be written in x minus c form. Please memorize that form of the divisor. All right, it's always in x minus c form. So I'm going to put x plus c 5 in that x minus c form. So x minus c is the form. Let's rewrite x plus 5 in x minus c form. So we have our x. We have to pull out a minus from the plus here. So minus, and then we have minus 5 for the value of c. So c is equal to minus 5, and that's the value we will be plugging in into the f of x function. So f of negative 5. All right, let's plug in minus 5 wherever there is an x in the function. So minus 5 squared, again, please use your brackets around the x replacement, plus 7 times minus 5 minus 20. All right. So in the next step, we will first evaluate the exponents, take care of the brackets rather. So minus 5 squared is positive 25, plus 7 times minus 5 is minus 35, minus 20. All right. So let's keep going. 3 times 25 is 75, minus 35, minus 20. We first do the subtraction. 75 minus 35 is 40. All right. Again, f of negative 5 equals 40 is what we get after subtracting 35 from 75, minus this 20 is 20. And that's exactly what we got when we performed the synthetic division. We got a remainder of 20. All right. You would get the same remainder if we worked the division using the long division method. All right. So that's what the remainder theorem is about. It just says that if you evaluate the dividend, using C as an input value, then you will come up with whatever the remainder is from the long division process, or synthetic division, from the polynomial division process, really. All right. Now on this slide, we are presented with an example explaining the use of the remainder theorem to evaluate a polynomial function. All right. So they've given us a function which is 3x cubed plus 4x squared minus 5x plus 3, and they say use the remainder theorem to find f of negative 4. Now we could just plug in negative 4 into this into this polynomial here and evaluate, but we are first going to perform the synthetic division, find what the remainder is, and then verify this remainder by evaluating the function with minus 4 as an input value. All right. So this will also be a review of the synthetic division process. So let's go through it. Now remember, this in the remainder theorem they said f of c. All right. So our c value is negative 4. Negative 4. We use synthetic division to divide. So in the synthetic division process, remember, we pull the coefficients of the different terms in the dividend. So they have 3 from the first term, plus 4 from the second term, then negative 5, and then finally plus 3. We write the synthetic division notation. All right. And then we write the C on the left hand side of the separator. So they have negative 4. All right. C in this case is whatever is inside the brackets in f of negative 4. What was the step first? For the first term, we write the number below the line, all right, below the line that we drew, separation line, and then we multiply minus 4 with 3. So minus 4 times 3 is negative 12. We write the answer, result of that, under the second term, which is plus 4. And then we perform the addition. So plus 4 plus minus 12 is negative 8. We repeat the process. Negative 4 times negative 8 is positive 32. We write the result under the next term, which is negative 5. So negative 5, and then negative 5 plus plus 32 is positive 27. Again, repeat the process. Minus 4 times 27 is minus 108, 108. We write that below the last term here. So plus 3 plus minus 108 is negative 105. So over here, after performing the synthetic division, that's where we stop, right? That we don't have to do any more steps. We figure out what the remainder is. The remainder is always the last term, is always the end result, whatever appears in the end column after we complete the synthetic division. In this case, minus 105. So that's what our remainder is. All right, that's the remainder. And by the remainder theorem, all right, f of negative 4, that means if we evaluated this function by replacing all the x values, let me replace the x with negative 4, negative 4 cube plus 4 times negative 4 squared minus 5 times negative 4 plus 3. All right. If we evaluate this function with negative 4, we should get an answer of negative 105. All right. So thus f of negative 4 equals negative 105 using or applying the remainder theorem. Now that we know about the remainder theorem, there's one other theorem we need to learn about. It's called the factor theorem. All right, the factor theorem is named such because it talks about the factors of a polynomial function. All right, remember we said that at the beginning of this presentation, we said we are going to deal with polynomials which are not factorable by the processes we had learned, we knew at that time. All right, now we know more ways of factoring, and one of them is by applying the factor theorem. So again, let's see what that states, and we are going to then go through an example. Let f of x be a polynomial. If f of c equals 0, then x minus c is a factor of f of x. All right. So what this is saying is, remember, c, f of c, and this is a follow up from the remainder theorem. F of c is always going to be the remainder after we perform polynomial division, right? That's what we stated in the remainder theorem. So let me write that down here. By the remainder theorem, it was stated that f of c will be equal to the remainder from a polynomial division. So when they say if f of c equals 0, that means they are saying that if we get a 0 for the remainder from a polynomial division, then x minus c, whatever we plugged in for c, is a factor of f of x. And then part B says if x minus c is a factor of f of x, then f of c equals 0. That's the converse of what was stated in A. So if f of c equal to 0, if the remainder is a 0, then we can be sure that x minus c is one of the factors of the polynomial f of x. Conversely, if x minus c is a factor of f of x, then f of c will be equal to 0. All right? And that's what the factor theorem is about. In the next slide, let's go through an example to understand what it means. Now let's go through this example of using the factor theorem. Now, we use the factor theorem to factor a polynomial which is otherwise not factorable using the techniques we know so far on factoring. All right. When a polynomial is not factorable, then we use the factor theorem to break it down into factors. The question says solve the equation for 15x cubed plus 14x squared minus 3x minus 2 equal to 0, given that minus 1 is a 0 of f of x. What that means is if we substitute negative 1 into the function, right, then we will get a 0. That means the remainder, in other words, from a synthetic division or a long division will be a 0. All right. So let's see what the solution is. We are given that minus 1 is a 0 of f of x equals 15x cubed plus 14x squared minus 3x equal to 2. How did they get the 2 on the other side? They rewrote this equation by moving the constant term minus 2 over to the other side. That's how they got the plus 2 on the other side. You see, the minus 2 is no longer there on the left hand side. So this means if when negative 1 is a 0 of the function, that means that f of negative 1 is equal to 0. So if we evaluated this function by plugging in negative 1 for all the x variables, we would get an answer of 0. Because f of negative 1 equals 0, the factor theorem tells us that x plus 1 is a factor of f of x. We'll use synthetic division to divide f of x by x plus 1. Now let me explain this. Why do they say x plus 1 is a factor of f of x? Although the negative 1 is a 0 of f of x, why do we have x plus 1? Now you may have already figured that out, but in case you haven't, then remember that the form of the divisor is x minus c. All right, so c is what negative 1 is. C equals negative 1. So if we plug in negative 1 for c into the x minus c form, it's going to be x minus and then negative 1. All right, which makes it x plus 1. So what they say is, what they're trying to say rather here is that if negative 1 is a 0 of the function, then that means if we put the negative 1, if we apply the negative 1 in x minus c, then x plus 1 is a factor, is one of the factors. Now this will have other factors as well, but x plus 1 is definitely a factor of this polynomial. Now in the next slide, they are performing a synthetic division using negative 1 for c to verify if the remainder is equal to 0 or not, if negative 1 is indeed a 0 of the function or not. So we'll use synthetic division to divide f of x by x plus 1. All right, so that's, and we said previously that this x plus 1 is going to be one of the factors of the polynomial. All right, so x plus 1 means c is negative 1, right? If we rewrite x plus 1 in the x minus c form, we will get c equals negative 1, and that's what they have here on the left hand side of the synthetic division notation. All right, so 15 plus 14 minus 3 and minus 2 are the coefficients of the dividend. we write them down, and then we start the process. The first term is written below the line 15, and then we um, continue with the synthetic division process. Minus 1 times 15 is negative 15, which is written under positive 14. Perform the addition, we get negative 1. Negative 1 times negative 1 is positive 1. Perform the addition, minus 3 plus 1 is negative 2. Minus 1 times negative 2 is positive 2. And then once we do the addition, negative 2 plus 2 is a 0, and we see the remainder is a 0. All right, so what we've done is, since we know that x plus 1 is one of the factors, we write this in factored form as x plus 1, and the other factor is 15x squared. Remember that the highest exponent in the polynomial example was x cubed. So when we rewrite the quotient, it should be 15x squared, 1 less than x cubed, minus 1x minus 2. And the other factor is the one that was given to us from the factor theorem, that's x plus 1. So now what we can do is we can see if 15x squared minus x minus 2 can be factored further. This is now a quadratic, all right, a quadratic, a polynomial here. All right, this is like a quadratic expression. So maybe using uh, the factoring method for quadratic expressions, we can factor it further. So we'll see what happens in the next slide. So now that we have used synthetic division to factor out 15x squared minus x minus 2 and x plus 1 as the other factor of the polynomial, which was given to us by the factor theorem. All right, we just need to factor 15x squared minus x minus 2. And when we did that using the factoring method, we get 3x plus 1 times 5x minus 2, and we see that the entire polynomial 15x cubed plus 14x squared minus 3x minus 2 is now in completely factored form. X plus 1, 3x plus 1, and 5x minus 2. And now we can equate each of these factors to 0, which they've done here. X plus 1 equal to 0, therefore x is negative 1. We knew that already, that was given to us. 3x plus 1 equal to 0, therefore x is negative 1/3. This is applying the zero factor property of solving an equation. And then 5x minus 2 equal to 0, therefore x equals 2/5. Therefore the solution set is minus 1 minus 1/3 and positive 2/5. So these values, the x values that we found, that we solved for, are also the zeros of the function. That means if we were to draw the graph of this polynomial, we